That's what you guys think it means, right? That's what you've been told so far in your education. You've been told if you have a question about science, the way that science works is you do a lab. And how do you do a lab? Well, your teacher hands you a photocopy of a handout, and you go into the lab and you follow that procedure and you write down whatever happens and then you answer the questions and turn it in. Is that accurate?
Yeah.
Okay. That is what science looks like in most middle schools and some high schools. It is not what science looks like in the real world. Science in the real world begins with exactly what we talked about last week. I do believe we talked about our dear friends, the redheads, right? So, science, real science, begins with observation, right? Observation that makes you do what? Ask a question. And after you ask that question, you do a little bit of so we've observed, we've asked a question, we do a little bit of research, we poke about whatever resource it was. Last week I think we looked at genetic home reference and talked about our friends the redheads and how they might have inherited that. And that research led us to do what? Ask a better question. Because sometimes the first question we ask when we look back on it, we're like, wow, now that I know things now, that was kind of a silly question. But now that I know stuff, I could ask probably a better question. And then after I ask a question, I hypothesize. I write a hypothesis. What is a hypothesis not? That's good. Not an educated guess, right? What is it? It's a prediction based on prior knowledge and evidence. So it's a prediction based on prior knowledge and evidence. Now, there is a good way to write a hypothesis. There's a bad way to write a hypothesis. The bad way to write a hypothesis sounds suspiciously like a blind guess. The correct way to write a hypothesis, in the way that scientists prefer our hypotheses, is to write what we would consider an if-then statement. If this, then that. So I'll give you an example of a hypothesis. If 3 times as much nitrogen fertilizer is added, then 3 times the amount of mass in beans will be produced. So the bean will produce 3 times more in grams. What do you think? What do you notice about that hypothesis? Down and then you guys can. Why is that a good or bad hypothesis based on what you think? Compared to this. A, 1, about the same? I have given you a standard for comparison. If fertilizer is added, then the beans will grow. This or B or 2. What do you guys think? 1, 2, or about the same? Let's vote. 1 is a better hypothesis. 2 is a better hypothesis. Or about the same. I can't tell the difference. I tell you what, the optometrist does that to me, it messes with my mind. Like, I always feel like there's a right answer and a wrong answer, and he's trying to bamboozle me into the wrong answer. All right, so we predominantly voted for hypothesis 1. It definitely had the most votes. Here's going to be the awful teacher thing I do to you. Why? I feel like when I ask why and Colton whines like it's painful, it makes me want to ask why more often.
Why? Oh, that was contagious.
I think because it was more specific. It wasn't just a general statement about this topic or a general question about this topic.
How many of you are like, I liked it because it was specific? Okay.
Like Patrick, it's specific and it has more description.
It wasn't just an obvious statement.
You can tell there's like prior knowledge or like research done.
Yeah, if you're going to say nitrogen fertilizer, that means you know something about fertilizer, doesn't it? Like, you didn't just say fertilizer. Like, it all means the same thing. 3 times was mentioned in both the if and the then. 3 times tells us we can do what?
Connect them.
So we've connected a relationship. We established a relationship that in this hypothesis we've said is linear, right? That's a linear prediction. It's a positive correlation. And we can also measure 3 times more of something, can't we? A good hypothesis is going to be specific. It is going to be descriptive. It's going to involve research and prior knowledge. It's going to give us some kind of predictive relationship. Preferably a mathematical one. One that we can actually use an equation to extrapolate from. I could say, all right, in my hypothesis I said 3 times 3 times, and that means if this is what my data says, then 1.5 times the fertilizer should produce 1.5 times the beans. It should also be measurable. You have to be able to measure these things. Without measurements, it's useless to a scientist. Doesn't mean anything to us. Like, oh, it turned blue. Okay, and what? Why? So these are what we're looking for when we write a good hypothesis. And if you've written a good hypothesis, your experimental design will naturally follow. Now, while I was out on retreat with you guys, I did give you what for a lot of you seems like an impossible task. I asked you to design your own experiment. And the reason that it seems like an impossible task is because you've never been asked to do it in that way before. When you've experimented, you've been given the list. I didn't give you the list. I said, you make the list for me. You tell me how this science thing works. In the real world, that is how it works. The scientist is the one who has to determine procedure. If they've done good research, if they've asked a good question, and if they've written a good hypothesis, experimental design naturally follows. If your question is bad, if your research is bad, if your hypothesis is bad, your design is going to be bad, right? Good begets good, all that, like, it's just not going to happen without something good. We write a hypothesis, and then you've done the scientific method so many times in your past that you know it cold. You know this. Yeah, you write an experiment. And every good experiment has what? What do you think? Constants? Every good experiment's going to have a control variable, an independent variable, and a dependent variable. How many variables do scientists test at a time? It was in your reading. 1, right? 1 variable at a time. Why don't we test like multiple? Why don't I add nitrogen fertilizer, then pour on some herbicide, and then add a little bit of phosphorus?
You want to know what each one will do in order to combine them all?
I confound the relationship if I combine them all. So it's not clear which caused which change. Now, one could infer that which one would be the deadly one. The nitrogen, the phosphorus, or the herbicide. The herbicide. Why would the herbicide be the deadly one? Yeah, it's designed to kill plants, right? Herb is the root for plant. Side is the root for death. You know, think about it. Genocide. What is genocide?
Side of a house. It's got side in it.
How does that even make sense?
Genocide. What's genocide?
It's like mass murder of a whole race.
Mass murder of an entire race, right? Suicide, homicide, all of these things, you know, pesticide. How many of you are like, hey, I never noticed that before? That's what I'm here for. All day. Well, okay, 6:30 to like 4, but still.
You get here at 6:30.
Mm-hmm. How else do you make 6:30 mass?
What time do you wake up?
5:08. Yeah, 5:10 is too late, but 5:05 sounds kind of heinous. 5:08 seemed pretty.
5:06 and 30 seconds.
There's extra 2 minutes for you.
You wake up.
All the difference in the world.
The side of your house is deadly. Got side in it.
CIDE, right?
Sure.
Yeah. So we're clear about the spelling. All of these things are going to have variables, and if you write your hypothesis the way that I've instructed you to, the independent and dependent variables will become very obvious. The independent variable is the if, the dependent variable is the then. That makes it easy peasy. I like things easy, I like things obvious. Good experiments will also involve, wait for it, same thing a good hypothesis has.
Teachers and students, please excuse the interruption.
Okay.
Sure, every